Good morning, students. Today we are going to see the differences between distance and displacement. So fine, see children, consider a particle started at A and it has to reach to the point B. So then it can go from A to B in this curved path, or it can go from A to B in this kind of path. This is the third path. Or it can go from A to B like this. I have shown here three different paths. Now see, my dear students, like we can draw different paths to move from A to B. Now distance means actual path followed by the body. If we follow this path, this actual length of the path. So actual length of the path is called distance. The actual length of the path is called the distance. So how much length we traveled or covered, that is called distance. And see, and the displacement means it is the shortest path. So between A to B, out of all the paths, this is the shortest path. So to get a shortest path from A to B, we should move in a specified direction from starting to ending. Our direction is from, my left to right. So my left to right. So we are moving in a specified direction. And this is also one of the path. And this is only the shortest path. And no path other than this can be shortest. So shortest path or the shortest distance also, it can be also called, it is also one of the distance. So shortest distance between the 2 points. Shortest distance between the 2 points or the shortest path is also called displacement. And with a small and clear analogy, we can say that this path can be shortest if we move in a specified direction. If we move in a particular direction only. So means that's why displacement has a direction. Displacement has a direction. Okay, students. So actual length of path. Actual length of path followed by the body is called distance. So actual length of the path followed by the body. If this is the length I follow, then this is the distance I will get. And this is the distance I will get. This is also one of the distance. So fine. Out of all these distance, which one is the shortest you see? That is the displacement. Okay, and now see, both are lengths only. So that is the length means its SI unit is meter, its SI unit is also meter, and the symbol for meter is M. The symbol for the meter is M, and CGS unit is centimeter. Here also CGS unit is centimeter. You are writing cm. And see, distance have no direction. You cannot say the direction. So here this is the direction at the starting instant. Just draw one tangent there, that is the direction. And here this is the direction. Here this is the direction. Everywhere you just draw a tangent, the direction is changing. So we cannot say the direction for distance. So it has no direction. It has only magnitude. That's why it is a scalar physical quantity. And see, you are telling the shortest distance. to obtain the shortest distance, we must move in a specified direction. We must move in a specified direction, you know that. That's why it is a vector quantity. It has magnitude, some 10 meters, 20 meters, 5 meters, or some value it will have, and it also has a direction and also satisfying the vector laws of addition. That's why it is a vector quantity. So it is a vector quantity. So displacement has both magnitude, direction, and also obeys the vector laws of addition. That's why displacement we can call it as a vector physical quantity. So fine. Now, and it can never be negative. For a moving body, distance won't be negative. So because it can never be negative or zero for a moving body. And that point I'll explain later. And see, students, and distance is not a unique path. It is not a unique path. Distance between 2 points, not a unique path. See, from A to B, I can go like this, I can go like this, or I can start here and go like this, or I can go like this. In any manner, we can go from A to B. That's why it's not a unique path. It's not a single path. Unique means single. It's not a unique path. And see, my dear students, displacement is a unique path, because from A to B, you should get a shortest distance. We should move in a specified direction. So we'll get a unique path to move from A to B, or between 2 points. So displacement between 2 points is a unique path. It is a unique path. It is not a unique path. Next, distance between 2 points gives the full information of the type of the path followed by the body. Distance between 2 points gives the full information of the type of the path followed by the body. So if you know this is the distance, you can say what kind of path it has followed. And if this is the positions you are going from, a particle going from A to B like this, and this is the path followed. So it gives a full information of the path, what path we have followed. You are saying the distance between 2 cities, or we are saying the distance between 2 towns or 2 cities, or between any 2 points. We are mentioning the path how we are following. So for example, A to B, I go from here to here, here like this. The joining of all the points, I will get a path. It gives the full information of the type of the path followed, and it does not give the full information of the path followed. So path means just line joining. If A to B, we can go in different manners. But displacement means I will go directly A to B. Even though you follow this kind of path, displacement, if I ask between A to B, if I ask the displacement between A to B, we will go in a specified direction. That's why it does not give the full information of the type of path followed by the body. And next, and it never decreases with time for a moving body, because it is moving, it will cover some distance. In whatever manner it can cover the distance. So the distance covered is called, what do you know? So that is what, it never decreases with time for a moving body. And it never zero also for a moving body. It cannot be zero. And it can decreases with time for a moving body. Those points we can see here. Now see, my dear students, a particle is started at A. It went from A to B, that is 3 kilometers, and B to C, or you take meters. So A to B 3 meters and B to C 4 meters. So I want to write the distance here. See, my dear students, for the distance I am using the letter S, and for the displacement I am using the letter S bar. So distance I am using the letter S, and displacement I am using the letter S bar. I want to write what is the distance and what is the displacement. So I want to write what is the distance and what is the displacement. See students, A to B we moved, B to C also we moved. So distance means the length of the path covered by the body. Means A to B we are covering 3 meters and B to C we are covering 4 meters. So it totally gives 7 meters for us. 7 meters for us. But if we ask the displacement in this situation, it is the line joining the initial point to the, it's a line joining the initial point to the final point. Irrespective of the path followed by the body, even though we follow this kind of path, we don't mind about the path followed, we don't bother about the path followed, simply we join from initial point to final point. So you go a direct line segment from initial to final. This is called displacement. And 3, 4, and you know this is right angle. So it will be 5 meters. So that's why you will get displacement is. So we'll get the displacement is 5 meters. Distance is 7 meters. So displacement is 5 meters. And now see students, if a particle starts at a point and returns to the same point, then its distance is said to be, see a particle is started here. So a particle is started here, see at this point, a particle is started here at this point. I projected up and reached to the same, my hand only. It reached to my hand. So it is upward h meters traveled, downward h meters traveled. So in this situation, distance I will get 2h, distance I will get 2h, and displacement I will get 0. So displacement I will get 0. Since initial point is O, it went to some height, h meters height, and again reached to O only. So it is reached to the same point. So displacement has become 0. So displacement has become 0 in that situation. Okay, students. So next one, O is a point, and this is the radius R, and this is the radius R. Okay, students. So a particle is started at, consider a circle with O as a center, R as a radius. A particle started here and again comes to here only. So initial point is A. If you consider final point B, so those both are coinciding. Here also we say that displacement is 0. In this situation also displacement I will say 0. But distance started here, and this total length of the circle it covered, a circumference of the circle it covered. So distance we will get 2 pi r, that is called circumference of the circle. We will write that as 2 pi r is the distance. 2 pi r is the distance, and the displacement is 0. And the next one you see, my dear students. So, and this is the point O. An ant is started here, a small ant is started here. It went 80 meters up and reached to here, and again reached to here. So in this situation you see the distance. Distance means 80 meters upward, 80 meters downward, 80 plus 80, and still 40 meters is covered down. So distance means we will get, so 80 plus 80 plus 40, 80 plus 80, 160, 160 plus 40, the distance you will get. So I am writing clearly here, 80 plus 80 plus 40. So then how much, my dear students? 80 plus 80, 160, 160 plus 40, so 200 centimeters. Displacement you will get 200 centimeters. And distance will get 200 centimeters. If I ask the displacement, this is the initial point, you know. This is the initial point, went up, came down, and still moved down. Means initial point and final point. So displacement will become minus 40 centimeters. So displacement in this situation will become minus 40 centimeters. So like displacement positive in this situation. In this situation displacement is 5 meters. It can be positive. Okay students, it can be 0 and it can be negative. So displacement can be positive, negative or 0. But see, distance is never 0 for a moving body. So distance can never be 0 if a body or a particle is in motion. So distance can never be 0. So never decreases with time for a moving body, even though it has reversed the direction. 80 centimeters upward, 80 centimeters downward. Okay. Or h meters upward, h meters downward. Totally 2 h meters is the distance covered. And displacement is 0. Okay students. So like this. And the next point. So you got this point. So it never decreases with time and it can decreases with time. So it can decreases with time and it can be negative also. We have seen when it has going up and reversing the direction, it decreases. And it started here and again comes here, displacement 0, but it is behind of the initial point. So the negative sign tells it is moving, it is behind the initial point. Is behind of the initial point, so minus 40 centimeters it is telling that. And next one, see, if a particle moves from A to B, this is the path followed, second path it followed, then this is only the distance, this is only the displacement. So if the path followed is only the shortest path, that is only distance, that is only displacement. So for example, see my dear students, this is a point, this is a point P, this is a point P. Now a particle has to reach the point Q. Now P to Q. It has gone from P to Q. It has gone from P to Q. Now see my dear students, and if P to Q, and this is the path followed, and if I give its value is some 25 centimeters, in this situation P to Q we reach like this. What is the distance? Means we covered this much of path. So distance I will get 25 unit centimeters. And displacement also I will get 25 centimeters. It is only the shortest path. That is only distance, that is only displacement. So sometimes distance and displacement can be equal if it is the shortest path. If it is only the shortest path, then distance and displacement can be equal. So now see another important point I forgot to mention here. And see my dear students, distance can never be negative. See in any situation 1, 2, 3, 4, 5, we did not get any negative value. So distance can never be negative. It can never be negative. It is always positive for a moving body. It can never be negative. There is no chance of negative and no chance of zero also. And it can be negative, zero or positive. See my dear students, sometimes you are getting negative value. Okay, if it is the behind of the initial point, okay, then the displacement will say negative. Okay, the negative sign indicates the opposite direction. So, and it is positive here and zero here and negative here. So, displacement is a vector quantity. It can be negative, positive or zero, the situations you are getting. And see my dear students, in this example, distance and displacement are equal. So, I forgot to write a point, I will write now. Now you see my dear students, in this situation, distance and displacement are equal. Distance and displacement are equal. Okay. And in any other case you see, if we move from A to B and B to C, displacement is 5 meters. Distance is 7 meters. So distance is greater than displacement. Either distance is equal to displacement or it is greater. In any situation you see, distance is more, displacement is less. Distance is more, displacement is less. Distance is more, displacement is less. More, maybe equal or greater. So distance either equal to displacement, only one case, that is the shortest path, or it can be greater than that. Means if I take the ratio of distance by displacement, this ratio I will get greater than or equal to 1. If they both are equal, the ratio is 1. If they both are equal, the ratio is 1. And if distance is greater than displacement, it is the greater than 1. And now see, and if I write here displacement either less than distance or it can be equal. You can write like that also. See my dear students, in this situation distance and displacement are equal. And remaining all the situations, displacement is less than the distance. Displacement is 5, distance is 4. So displacement is less than distance. Displacement 0, distance is 2h. Displacement 0, distance is 2 pi r in this situation. That's why the displacement, so displacement less than the distance are equal. So displacement is less than the distance are equal. If I write this ratio, displacement by distance ratio I'll get less than or is equal to 1. I'll get the ratio less than or is equal to 1. So these are the differences between displacement and distance.